Right, let's jump back over to the lecture. We just did this example. So you'll get some of these, right? Where, how is something moving, velocity, acceleration. Those are fun. A couple more to wrap up our conversation. A ball is launched vertically upward with height in feet. H of t equals 60t minus 16t squared after t seconds. So it's just going straight up and down. But the height we can describe like a parabola as time is going by, right? It's going up, reaches the top, and then falls back down. At what time does the ball reach its maximum height? Okay. And then what is the maximum height? All right. And then the second example we'll do here in a moment. This is kind of interesting, a little bit more conceptual. In a factory, the average productivity of all employees is denoted capital A of X, where X is the number of workers. If the derivative A prime of X is positive, should the company hire more workers or let some go? Okay, we'll look at both of these. Let me switch over. All right, we've got H of t equals 60t minus 16t squared. What time is the maximum height? Essentially that question. Say, okay, so what's happening? All right. It's this shape like so, where this is the height and this is time. So we're thinking, what time does that maximum height occur? How are derivatives going to be helpful here? You know, kind of in one respect, we notice, well, that's the vertex of the parabola. If we can find the vertex, we can answer it. Yeah, we could do this with pre-calculus methods, but it turns out calculus methods are going to be really fast as well. Let's see, where does that height occur? Well, what's happening with the derivative right there, right? The slope of the tangent line is horizontal, or the tangent line is horizontal. The slope is 0, right? So what we can do is find when the derivative of our height is equal to 0. What time causes the derivative to equal 0? You might even think of the derivative of the height as the velocity. And that makes sense, right? The ball has this positive velocity. It gets to the very top, and just for an instant, its velocity equals 0. And then it starts to fall and its velocity becomes negative. It's kind of cool. Okay, let's see. Well, our derivative, not too bad, 60 minus 32t. And so if we set that equal to 0 and solve for t, let's see, 60 equals 32t. We divide, see, I think we can divide them both by 4. 60 over 32 would be 15 over 8. Or if you like the decimal, that works. 15 over 8 seconds. Or if you prefer the decimal value, 1.875. 15 over 8, yeah, 1.875 seconds would work also. Part B of this question, what is the maximum height? So we know when it occurs, but how high up is that? Well, if we know the time that it occurs, It's just a matter of plugging that in to the original height. We could say this is h of 1.875. 60 times 1.875 minus 16 times 1.875 squared. Yeah, let's find out. 60 times 1.875 minus 16 times 1.875 squared. I did something wrong there. 1.875. Missed a decimal point or something. There it is. 56.25 is what I got. What are the units there? Well, it's just a height, so that's feet. Pretty high, 56 feet, pretty good. Okay, very cool. Have that one last example. This one's interesting. We just copied the essential parts of it. We were told in a factory, the average productivity is A of X. The average productivity for all of the employees. X is the number of employees. Then they said, if A prime of X is positive, should they hire more workers or let some people go? And of course, the idea is they want to have the highest productivity. So if your average productivity, if the rate of change of your average productivity is positive, do you want to hire more workers or do you want to let them go? Let's think about this. Just kind of think, even like create a graph or a sketch of what it might look like, and then maybe we can answer this. A prime of X being greater than 0. What does that mean? That means the slope of the tangent of A of X is positive. So if I do a quick sketch here, let's say this is the number of workers, X. And this is the average productivity. All right, so this is a graph of A of X. So we're told that the slope of the tangent line of A of X is positive. So I'm not really sure what's happening, but if we were to look at A of X, it's increasing. It's going up. So maybe like here's where X occurs. The slope of that tangent line is positive, so it's got to be going up. So then the question is, okay, if that's true, then should this company hire more workers or should they let some go? You think, okay, so if they hire more workers, it could be that even hiring more people, the average productivity goes up for everyone. Everyone's productivity goes up. It probably is more intuitive that if you hire more people, everybody's average productivity goes down, right? Like if you thought there's only so much work to do, so if you hire more people, then there's not as much work to go around. And that could be, and then you'd want to let some people go. But if it is possible that you might hire more people and everyone's average productivity actually increases, maybe it makes it more efficient. Maybe like, you know what, we really need to, like in this factory, we want to like specialize a little bit more. Like I just want some employees only doing one job, and they get really good at that one job, and they're super efficient. They don't have to walk all over the factory. They just stay in their one area, and they know exactly what they're doing. They do the same thing all day. And then these new people I hired, they can do this other thing all day, right? Maybe where before the previous people were doing multiple things, and it slowed them down because they had to kind of move around and remember how to do. Okay. Amazon, from what I hear, I know a few people that worked at Amazon or work there currently, and that's what it is. You do the same thing all day, and you just work on the one floor of the factory, and you're really good at what you do. Which in that case, maybe you want to hire more people, and then everybody's more productive. What's the case here? Well, if the slope of this is positive, here's what's happening. If they were to increase the number of workers, what would happen to the average productivity? If they were to get more workers, then the average productivity would jump. And not only would those new workers be productive, but everybody else is more productive than they were before under this situation where a prime of x is positive. So what do they want to do? They want to hire, in this case, hire more workers. And there you go. Okay, well, that's it. That's all I had to chat about for 3.7. You're gonna get some questions that are similar to some of the ones we just did here. You're gonna get some questions that are a little bit different, and think about those, but maybe you can connect those ideas back, and kind of always be thinking for these more conceptual questions, if there are some of those, what are they really saying? What do I know about the derivative? That sort of thing. Okay, that's it for 3.7. Check out the homework.